One of the skills you're going to need to be able to do for Chapter 3 and for the AP exam is to read a computer printout of data and understand what it's telling you. One of the most popular ones they use is from a program called Minitab, and it looks similar to the printout you see down here. So I'm going to go ahead and read this, and we're going to talk about what these things are and how they work, and what we're actually looking at. So it says, are jet skis dangerous? Propelled by a stream of pressurized water, jet skis and other so-called wet bikes carry from 1 to 3 people, retail for an average price of $5,700, and have become one of the most popular types of recreational vehicles sold today. But critics say that they're noisy, dangerous, and damaging to the environment. An article in the August 1997 issue of the Journal of American Medical Association reported on a survey that tracked emergency room visits at randomly selected hospitals nationwide. The study recorded data on the number of jet skis in use, so that's one of the variables, and the number of accidents for the years 1987 to 1996. Computer output and residual plot from the linear regression analysis of the data are shown in this printout. So basically what you really just need to know is how do you take this data, what parts do you see here, just identifying them and using that to write the equation of the least squares regression line. So first of all, let's look at down this column right here. Notice it says predictor. The two things under predictor are constant and jet skis. So the jet skis is the variable x, and the constant is the y-intercept. Now, when you do this for other problems, the word jet skis is going to change, but the word constant will always be one of the words you're going to see under there. But that second word, the actual variable, will change depending on the context of the problem. So this context of this problem is talking about jet skis. That's why we see jet skis. You just need to realize that that's the x. That's the explanatory variable. Now, the coef, this column, is actually giving the equation to you. So it's like the coefficient, or what's attached to it. So the constant, or the y-intercept, is negative 0.8. And with jet skis, that's coefficient is 0.004838. So that is the slope that they're talking about. So don't let that word coefficient confuse you. That just is actually giving you the numbers for these things. Now for this part, we're not going to worry about that right now. We kind of do that in chapter 12. These two, same idea. We can skip that for now. That's chapter 12. You'll come back to that later. This S is the standard deviation of the residuals. We also have R squared right here. And you're never going to use the adjusted R squared. So, don't worry about the adjusted part. But this right here is R squared. And so those are the different parts that you see here. So from this, we should be able to get the R squared and the R and the equation of the least squares regression line. So based on this printout, our equation would be y hat equals, we want to do the coefficient, the slope is 0.0048308 x minus 0.8. And of course, you should always tell me what these two variables mean. I'm going to skip that for now because you already seen that. I also want to point out you can get R from this because we have R squared, which is 98.2%. So if R squared is 98.2% or 0.982, we can square root both sides. And we get the R is about 0.991. Now, you also need to realize that this could have been positive or negative, and you can tell what it is by looking at the slope. If the slope was positive, then your R is going to be positive. If it was negative, then your R is also going to be negative. So your slope and your correlation will always match.